This is Unit 2, Cramer's rule. Our objectives are to solve a two-variable system of linear equations using Cramer's rule, solve a three-variable system of linear equations using Cramer's rule, and to show an application that can be solved by using a three-variable system of equations. First, we're going to solve two-variable system of equations. Okay, so this is our system of equation that we're using as an example. And our first step is to set up the matrices. Okay, so the first matrix we set up, we use the coefficients. So since there's 1 in front of the x, which you just pretend is there, it's 1 and then 12 in front of y, and then -1 in front of this x and 8 in front of that y. And then our constant matrix is using from the equation, that the system of equations over here, the 68 and the 12. Our other two matrices that we're going to use, what we do is you replace the first row with your constants. And then in the second one, you replace your second row with your constants. Step 2 is to find the determinants of each matrix. Okay, so for our first matrix, we're going to find the determinant by doing 1 times 8 minus 12 times -1. And you get 20, and you should already know how to find the determinant. And so for this one, you'll get 400, and this one you'll get 80. Step 3 is to solve for x and y. So when we solve for x, we're going to take our matrix where we replaced the first row. We're going to take the determinant of that, which is 400, and we're going to take it over this, which is 20. So, and then for y, we're going to take our 80 and put it over 20. And so then we'll get 4 and 20. Step 4, you're going to check your solutions by plugging them back into the original equations. And when we did that, it works.
Solve three-variable system of equations using Cramer's rule. Alright, so our system of equations is x plus y plus z equals 4, 4x plus 5y equals 4, and y minus 3z equals -9. Step 1, we have to set up our matrices. So our first matrix is our coefficient. So we use that by figuring out the numbers. So for x is 1, 1, 1, and 1. That's why you have that. 4, 5, and then there's no z. And there's no x on this one, so 0, 1, -3. And then we do our constant, so that's 4, 4, and -9. Alright, so for our other matrices, you're going to, like we did before, you're going to replace a row, so the first row for the first one, and so on, with the constant. So for dx, we replaced the first row in this coefficient with the constants. For dy, we replace the second row, and dz, we replace the third row. In step 2, we're going to find the determinant of each matrix. So our original matrix, which was D, you just do the determinant times the matrix, and you do that for all of them. So to define the determinant, we plug the matrices into the calculator and use that to find the determinant, because they're 3 by 3 matrices, which we only do the determinant of 2 by 2. So we found that d equals 1, dx equals 1, dy equals 0, and dz equals 3. Step 3 is to solve for x, y, and z. So our equations are x equals dx over d, y equals dy over d, and z equals dz over d. So we plug in the values that we found. So we know d equals 1, so we put 1 over 1, or dx equals 1 and d equals 1, so 1 over 1. dy is 0 and d is 1, and then dz is 3 and d is 1. So you may have noticed that the determinant for dy is 0, and we've been taught that the determinant cannot equal 0. But since we saw down here that the 0 ends up being at the top of the fraction, then it doesn't affect the outcome, so that is fine. So the final answers are x equals 1, y equals 0, and z equals 3. 4 is to check your solutions. We plugged it into the calculator and they work.
Okay, now we're going to solve a story problem with 3 variables using Cramer's rule. Alright, so our story problem is a vendor sells hot dogs, chips, and drinks. A customer buys 2 hot dogs, 5 chips, and 2 drinks for $10.50. A hot dog is 50 cents more than chips, and 1 drink is $1.75 less than 2 hot dogs. So we're going to solve for x, y, and z, which are x is the cost of the hot dog, y is the cost of the chips, and z is the cost of the drinks. Okay, so our first step is to make a system of equations. Our first equation will go back, so we have 2x, which is 2 hot dogs, and here it says we have 2 hot dogs. And then 5y, which is 5 chips, and 2z, which is 2 drinks, and all that together is $10.50. Our second equation is x minus y equals 0.5, which is saying that since a hot dog is 50 cents more than chips, a hot dog minus the cost of a hot dog minus the cost of chips is 50 cents. And our third equation is 2x minus z equals 1.75, which is showing that 1 drink is $1.75 less than 2 hot dogs.
Step 2 is to set up matrices. So first we're going to do the coefficient, and we got that by looking at the values before the variables. So 2, 5, and 2, like we went here. 1, -1, and there's no z, so 0. 2, 0, because there's no y, and -1, because there's -z. And then our constant, so we found those by what is on the right side of the equation, so 10.5, 0.5, and 1.75. All right, to find the other matrices, you replace a row with the constants to find the others. So like we've been doing. So first one, we replace the first row, for dx, dy replace the second row, and dz we replace the third row. Step 3 is to find the determinants of each matrix. So the determinant for d and the determinant for dx, dy, and dz. All right, so we found that d equals 11, dx equals 16.5, dy is 11, and dz is 13.75. Step 4 is to solve for x, y, and z. Our equations are dx over d, dy over d, and dz over d. So when we take our values and plug them in, so d is 11, so that means all the denominators are 11. And then we plug in dx is 16.5, dy is 11, and dz is 13.75. When you simplify these, you get 1.5, 1, and 1.25. So then we're going to check our answer, and it works. 6 is to write out your answers, since it's a story problem. So we said hot dogs X are $1.50 each, chips Y are $1 each, and drinks Z are $1.25 each. This is Jacqueline
And Annie explaining Cramer's rule.
See you next time.